Okay, so we already did the geometry definition using SolidWorks, the hydrodynamic parameters of the frequency domain that we did it using ANSYS Aqua, and now we're going to go for the simulation that we're going to do first of all with the WEC-Sim. Okay, so I just created a folder inside the WEC-Sim master folder if you have already downloaded the program, and it has to contain triple files that we're gonna build right now. One is the WEC-Sim input file, the user-defined functions, and the model, the simulated model. After that, it has to contain three folders: the output, which is an empty folder, the hydro data, that is the folder. Let's go for the hydro data. It's the folder that contains the bemio.m and also analysis.list and analysis.ah1 that are the outputs that we got from the ANSYS simulation. Okay, just copy that and put it here. And finally, the geometry file, which contains the cylinder STL file that we got from SolidWorks. So first of all, we're going to go for the hydro data. Here we have this Bemio file that what Bemio does is to convert the output from WAMID, Captain, Nemo, or Aqua into a file that can be read by the WEC-Sim solver. Okay, so there are many things right here, and we're just going to go for the examples in source, functions, Bemio. Here you can see that there are many functions, just like read WAMID, read Nemo. These functions allow you to read other kind of files, not only Aqua, but other files. So you get the output from Nemo, for instance, and use read Nemo on the hydro structure, and it will put the hydrodynamic parameters to the hydro structure that is going to be used here to write the Bemio H5 file. In this case, we're going to use Aqua, which requires the analysis H1 and analysis.list files. Okay, but there are many functions here. For instance, we can see the plot added mass. We can just put here plot added mass, and the input is hydro. So we can simply plot the added mass as is. It comes from the hydrodynamic parameters. So let's just run this and change folder. We're going to see here, as I'm doing two plots added mass and excitation magnitude, we're going to see these two pictures right here, and also the important part that is the H5 file. So let's wait for a second. Okay, so we got here the normalized added mass. We can see it for the shorts, for the heave, and for the pitch. We can close it as it's gonna be safe right here. So I'm gonna close this one, and also the normalized excitation force magnitude that we also gonna close. But just note that you can plot all these hydrodynamic parameters using Bemio. Don't require the WEC-Sim. So I'm gonna close that, and this is finishing. Yes, the analysis.h5 file format. Okay, so we don't need to do anything else here, and let's just keep going. We have finished with that. We don't need to do anything with output. We don't need to do anything with geometry. We included that, the body part. So let's go for the other ones. First, the simulated model. The simulated model is as simple as this right here. Okay, this will be the seabed, which is the global reference frame. This would be the power takeoff. It's a translational power takeoff, and this would be the body, our rigid body. He doesn't know what this is, so we're going to find this on one of the two files that are remaining already. But in fact, here there's a library with WEC-Sim that you can put your body elements: flex body, rigid body, their power takeoffs, rotational, spherical. There are many things that we can do on this, but we're just beginning with a simple example. For you to know, this would be, for instance, a more complex wave energy converter, but with a a body and a floating body, so they have also constraints between those two bodies that we are not using right now, but this can also be done. Okay, so if this is clear, I can close this and let's go for the other two files. First, the WEC-Sim input file, which is this one over here. Here we define many things. First of all, the environment, the simulation start time, run time, end time. Runtime, for instance, is the waves that the sea begins flat and it begins the wave generation until it becomes a developed sea, okay? Also parameters for ParView that we're gonna see later and many other things. Apart from that, we also have to define the waves. In this case, it's irregular waves that we see that we can put regular waves, regular thick waves, many other things that are documented on the WEC-Sim documentation or also on my thesis. Also, in this case, we're going to use the George Schwab spectrum, but we know that there are more spectrums that we can use. So here's the definition for the waves. After that, we have to define the body, and this is the name. Body 1 is the name that we gave to the simulated model. And here we specify its hydrodynamic parameters, which are on the H5 file that we generated before. We have to specify the geometry file for the plot, and also the mass, the inertia, and the initial displacement. Finally, we're going to go for the translational PTO, the stiffness, the damping, etc. We have to know that if there are constraints, we should also put the constraints. Maybe there's a translational constraint, I don't know, depending on the design or rotational constraint. So we should put it right here, okay? I'm gonna run this. Okay, everything good. After that, there's the user-defined functions. This MATLAB script is used only for plot. Check that here's plot spectrum, plot response, plot forces, and now we're gonna see how are we using it. So we can write here, after running the WEC-Sim input file, we can put WEC-Sim and just wait. Okay, so the first thing we can see over here, this is not our final simulation because we're going to use ParView, but this is the first approach of what it would be. We cannot see the waves here, that's why we're going to use ParView. But this would be our plotted solver with the frequency of the waves that we put, with the height of the waves that we put, and we can see movement, and that makes really a lot of sense. But we still have to check many other things, okay? We can put it in higher speed to see how it moves. At this moment, the program is writing the ParView files. So a file has been created right here, the VTK file, that now we're going to learn how to use it on ParView. Okay, so one thing that I did on the user-defined functions is to plot all the forces. Of course, I plot all of them on the same plot, and it's difficult to interpret, but for the user purposes, we can split them, see the force we're interested in, but there are many forces here, and it's so easy to analyze all of them. After that, we have here the position, velocity, and acceleration. We're going to dismiss the starting part, which is the ramp, but we're going to go for the rest. Okay, this would be the position, velocity, and acceleration. After that, we can also see the John Schwab spectrum, the wave surface elevation, and the wave surface elevation, but here's a mark of the ramp which starts at 10 seconds, okay? You can see like at the beginning there's no wave and it begins the elevation. Okay, so these are really cool things that we can do with WEC-Sim, and we can export all this data and use it for our purpose, and also set parameters, damping from the PTO, stiffness, etc. And now we're gonna go for something really interesting, which is this over here. We're gonna try to open the PVD. In my case, it recognizes that it has to open it with ParaView. If not, you can go to ParaView, open file, and try to open the PVD. I'm just gonna double click it. Okay, close. Okay, when you got it like that, you have to put the A right here, and you see that this is our simulation on an interval of, I think it's 10 seconds. So there's not much happening right here, but we would like some better resolution. No? So we're gonna press this macro right here, which is WEC-Sim. Okay, now much better for sure. We're just gonna play it again. We can see our point absorber with the waves, but there are more things that we can do with ParaView. Apart from that, we can improve our wave like this. We can see the elevation of the wave. Let me just play it again. Okay. Okay, so using WEC-Sim is something really simple. We did it using MATLAB. You see that we had some WEC-Sim libraries that got installed when we use WEC-Sim. We can plot all the forces, we can get data from all the forces. It can be done really easily, and we can plot graphics just like that because they create our ParaView files. So I think ParaView is WEC-Sim is a really useful tool with whom you can model nearly every wave energy converter. You should really try to model some more complex stuff. There are also examples of other wave energy converters, but this is the simple case of the point absorber. So in the next video, what we're going to do is see the difference between that and the polytechnic solution, which is part of the thesis.